the Monterey Institute of International Relations, but she came up here to do some work with PVDS, and as part of that work, she's been looking at a life cycle analysis of hemp and how hemp might be used in different ways. And as some of you may know, DIRTT's constantly looking at alternative materials that we could be using for tile, for insulation, there are all kinds of things we've looked at. Hemp keeps coming up. And I think Hemp's day is almost upon us, not quite. There's still some marketing problems that have to be worked out, and also in terms of how it gets used. But we're really close, and so I'm looking forward to what Annie has to say. Annie,
Thank you.
the floor is yours.
My last name is actually pronounced Rouse. Rouse, you will know. But it's nice to be here today, and thank you for having me. So I received a U.S. Fulbright scholarship back in September. Actually, it was before then, but I moved to Calgary in September to study life cycle assessment. So for those of you who maybe don't know what life cycle assessment is, I'm going to review what that is and then how it applies to the research that I'm conducting while here. So what is life cycle assessment, also known as LCA? So it's a compilation and evaluation of inputs and outputs through the natural system and the technical system into a product and through the supply chain of that product to its final disposal. So you could either conduct a life cycle assessment potentially from cradle to grave, which would be from raw material to distribution, from cradle to gate, or sorry, I messed that up. Cradle to gate would be raw material to distribution. Cradle to grave would be raw material to landfill. And cradle to cradle would be raw material to reuse of some sort. So this is producers and manufacturers and different companies are finding LCA to be more important within their business strategy, because you can, for instance, someone like Coca-Cola could look and maybe they want to compare the environmental impact between using aluminum or plastics. So they can do a life cycle impact assessment and figure out what their best choice might be. Companies can also use it with evaluating maybe where their biggest energy losses are and how they can create efficiency throughout the supply chain along the way. So, and they could also use it to compare other products. So maybe you want to compare a DIRTT product with another company's products that they're creating, and you can really measure the impact and say, well, my product's better than yours is because of this, that, and the other. So you all want to kind of define these things within the goal and scope definition. So life cycle assessment is broken down into 4 different phases, 3 of which are done in order, and then the interpretation phase is really done throughout the whole process. So within the goal and scope definition, you would want to make these decisions on if the report's supposed to be internal or external reporting. So if it's internal, you would model it a different way than if it were to be external. Additionally, you'd want to define and that would be with the decision of defining your audience. You also want to define the boundaries. So do you include infrastructure? Do you include packaging, transportation? These are all inputs and flows that could potentially have a large impact within the assessment. You also, in this stage, you choose your actual impact assessment methodology and the categories, the impact categories that go along with it. So your impact assessment categories are broadly categorized under human health, which something like carcinogens or non-carcinogens would be within that. Resource use, which would be something like fossil fuel depletion. And within ecotoxicity, so that would be more like your eutrophication and acidification potentials. So these are all defined within the goal and scope definition and within your impact assessment methodology. And you would also choose your impact assessment methodology based on what you're actually trying to accomplish. So there's all sorts of methodologies to choose from. For instance, the IPCC methodology, which is the International Panel for Climate Change, measures or focuses specifically on the global warming potential. So if you wanted to look at that within your product, then you would maybe want to focus on that. There's also BEES, which stands for Building for Economic and Environmental Sustainability. So a company like DIRTT may want to focus on the BEES methodology. There's also Tracy, which focuses on geographic location. So that is what I'm using within my methodology, within my study, because it has a North American focus. So the next step in the life cycle assessment is your inventory analysis. So this is actually your data collection phase, where you would contact suppliers, distributors, get your own personal information, or maybe through secondary literature. So usually when you're conducting a life cycle assessment, you'll be using a software, which makes it 1,000 times easier. So something like within a semi-pro software, which is a software that I'm using, you would find something like this, which maybe is difficult to see. But at the top, it says known outputs to Technosphere. So these are your products or your co-products. So I chose medium density fiberboard because I know that you all use it a lot here. And you can see that that's in the blue. So you have your amount, which is 1, and then your unit, which is a metric cubic meter of medium density fiberboard. So below that are all the inputs from nature and from the Technosphere, which is more like the man-made side of products. And so you want to relate all of your inputs to the product that you're describing. So in this sense, all of your water, you can see that it's a known input from nature and that you need the specified amounts of water from different sources to create the 1 metric cube of medium density fiberboard. You also need urea formaldehyde resin, so you would need 47.5 kilograms of urea formaldehyde resin to create that 1 MDF. You also need residual wood, pulp wood, both in dry and hardwood and softwood form. You would need aluminum sulfate powder, paraffin, and then your infrastructure, which is the wooden board factory. And then you also have your heat and electric needs. And in this case, the medium density fiberboard is actually looking at Europe as a whole. So it takes you can see that there's tons of different electricity choices. So there's Germany and Hungary and Romania and all sorts of countries throughout Europe, so you can figure out what the actual electric needs are by country as well. And then at the bottom you have your outputs. So these are your emissions to air, emissions to water, and emissions to soil. So these, along with the inputs from nature, are considered elementary flows because they flow directly from nature or directly into nature without anthropogenic change, except for within the product. So then it also creates the actual inventory. So you can see that on the right where there's the X's, so that's the actual product that you're looking at. But then everything to the right is all of the different inputs. So you have your urea, your urea formaldehyde, your different woods, and then you can see that there's all sorts of substances. There's only a few in this example, but the whole list is actually 1,237 substances total that go into the process of making MDF board, one cubic meter of MDF board. And yeah, so then it has all the different amounts that each would need. So the third part of your assessment is the actual impact assessment. So this is actually taking all of your inputs from nature and from the Technosphere and all of your outputs, and it measures them and quantifies them into different impact categories that I was speaking to earlier. So like your global warming potential, eutrophication potential, these are all within the impact assessment. So in this sense, you can see a large network, and this is within the global warming potential. So you can see that the medium density fiberboard, the urea formaldehyde has a relatively large impact. The size of the red lines signify the weight. So you can tell that the urea formaldehyde has a large impact, but it's not quite as large as maybe the heat is, which has the most overall. And then, as I stated earlier, the last phase is interpretation, but this is really done throughout the whole process. So you want to consistently look over your results, you want to identify outliers, you want to see sensitive areas, and those sensitive areas might be areas where you would want to have the most accurate data possible. So what I'm doing within my life cycle assessment is actually looking at industrial hemp as a building material. And so most Canadians are a lot more aware of the impacts of industrial hemp than a lot of US citizens, but just in case you're not, in case you don't know what hemp is, it's a fibrous crop that's grown throughout Europe mostly and China for the textiles and here for the grain. But Canada is actually moving a little bit more towards fiber industries as companies have started to move into the area, specifically within Alberta. So when you process the fiber or the straw, it actually has 3 different co-products. So one of which is the technical fibers. So these are the actual exterior bast fibers. So you can see kind of in here, this is different processing stages. So you can see it gets smaller and smaller, but it's the actual, when grown and processed accurately, it's considered the strongest natural fiber in the world. So if you pass it around. There's
No way.
I didn't really think about that. So there's actually a company that's moving in operations into Alberta. They were originally based in China and in Australia, and their new company that'll be producing components here in Alberta, just outside of Calgary, is called Scilab International Alberta Limited, and they're actually creating biocomposites. So this is a biocomposite form that actually has load-bearing strength, which is something that most previous hemp products don't actually have, but this guy actually has defeated that. And so this is actually almost entirely made of hemp, so even the resin that binds the fibers together is made from the seed, which creates an oil and therefore the resin. And so this actually could be used within buildings, just like that. And it could also, because it comes from a mat, it could actually be formed into pretty much any shape your mold has. So if you wanted to make a bike frame, if you wanted to make a water bottle, whatever mold you have and whatever you desire, it can create. He also has a...
Can we see that?
Yeah. Also has a cement pour. So this is actually, I don't know exactly what's in it, because he doesn't tell me, but it has the fiber, the hemp fibers in it, and it actually is 100 MPa compressive strength, and the pour does not need the use of rebar. So that's another good quality of those products. So another part of the hemp fiber is the core or the herb. So this is actually what a lot of the construction has been using in the recent past and current state. So this is actually what this is made out of, and it's additionally what a lot of the European houses are made out of. So when you mix the hemp hurd with a lime binder, it's called Hempcrete. And so in Europe, they originally started modeling these houses with a timber frame because it doesn't have a load-bearing strength like those products do there. But so you would create the timber frame and then have tampon the lime binder and hemp hurd within formwork, movable formwork, and then you have a wall. And so this actually, the United Kingdom, which I think maybe there's a man named Mike Duckett, I don't know if he came and spoke, he actually gave a presentation.
He didn't give a presentation, but he spent a fair amount of time here.
Okay, so his company, Stemia, has been creating these panels that you actually create off-site, and then once the structure of the building is put together, then they actually just go and install them directly into the facility. So you can see the structure is up and they literally just put them in, and it's not just residential areas, but it's also commercial buildings as well. So, and this isn't just throughout the United Kingdom, it's in Europe, it's all over the world. So in the upper left is actually a house in South Africa. The upper right is in North Carolina. The bottom right is in the United Kingdom. And the bottom left is actually a 300-year-old home in Japan. And so you can see that some of the qualities of hemp are that its longevity and durability. 300 years is an incredibly long time. And as well as you can create a rounded building. It doesn't have to just be rectangular. Another benefit of the product is its natural fire retardancy. So I was able to take a building course, and they actually did a fire test. So this has actually been on the wall already for 2 minutes, and this is just a precasted hemp wall with a lime binder. So you can see that it's not creating that much of an impact, and I'll let it keep rolling as I keep speaking. There's also other benefits to it. So a wall made out of the biofiber hemp blocks with the hollow fill has an R value of 10.4, and when done with an actual timber frame and how the Europeans do it, it actually has an R value of about 30. And so you can see that it would lead to reductions in energy costs as well as heating and cooling. Well, it would all be
What's the
energy
average
costs.
house here, over R12?
It's legal to build to R12. Most new houses would be built to about R18 or R20. But it's still legal to build to R12.
So it would save you leaps and bounds in Canada and heating. And so besides those qualities, it minimizes thermal bridging. It has breathability because it's a natural material. And you can see this guy's about to actually put his hand on it, unless it already happened. I think it did. But basically he was saying with his hand, oh yeah, there it is. So where he's touching right now is all cold. And it's a little warm where his pointer finger is, and then right on the black surface is where it's hot. And so that's after 3.5 minutes of burning of a straight torch. So there's also, it's non-toxic natural material and is locally grown here in Alberta. And additionally, I know that DIRTT looks a lot for sound absorbency quality. And there was a test done, I don't know a whole lot about this subject, so I won't pretend that I do, but there was a test done that had a polypropylene composite, and they had one that was straight polypropylene and one that had a hemp filler, 40% hemp filler, and they found that within the 1,000 to 3,000 hertz range, the sound absorbency coefficient was about 5 to 10%, but then once it hit 4,000, the composites that held the hemp fibers actually spiked up to 25 to 30% range. So it outperformed the composite that was just straight polypropylene by a whole lot, because actually the polypropylene one reduced in sound absorbency quality. So within my study, I'm actually doing a comparative analysis. So the upper right or upper left is the block wall that I have created. So it has a 20 millimeter line render followed by the biofiber hemp blocks. So that is this here, although this is only half of one. So imagine it has two. So these are very similar to cinder block in size, but they're lighter. The full thing is only 7.5 kilograms. But it doesn't have a compressive strength like cinder block does. But as I said before, it has the high R value quality. So therefore, since it doesn't have a compressive strength, it can't be a load-bearing material. So there's a timber frame after the biofiber hemp block, and then the timber frame is actually filled with Hempcrete that extends 50 millimeters beyond the actual wall, and then it's covered with a gypsum plaster. And the bottom right is my comparison product. So this is a cement render with the cinder block that are filled with perlite loose fill insulation. And then followed by that is a 4-inch cavity with perlite loose fill insulation and wooden timber furrings, and then a gypsum plaster board. So the funny thing with processing hemp fibers is that I mentioned that there was a third product when processing, but I've only said 2 so far. The third product is actually a dust. So the dust currently in most facilities is actually just used, it's either bagged and sold as an absorbent material, or it's just thrown as compost. So when modeling in that sense, you can see the results that have transformed. So you have your percentage of impact and ozone depletion, global warming, smog, acidification, eutrophication, carcinogens, carcinogens, respiratory effects, ecotoxicity, and fossil fuel depletion. So you can see that the hemp core fibers are actually in pink. So the non-carcinogens is a negative impact, and this is actually because hemp is a bioremediating crop. So it'll pull out more heavy metals from the soil than what it actually is putting in. And that's the same with carcinogens, and why ecotoxicity is also in the negatives. And then you can see in the other categories that the pink is very small relative to the other areas like the green, which unfortunately I cannot tell you what they are because it's a proprietary blend. So the second way that you can use the dust is actually how the Lethbridge facility will use it, and they're going to be using it in an anaerobic digester. So this will actually create energy for the plant and for the digester. So when modeled in that sense, the hemp cores actually had a negative impact completely across the board. So it's a large change between the two, and you could see why something like sensitivity analysis or the like would be very important for going forward with work. So then when actually comparing the two walls to each other, so both instances of the biofiber block wall, so with the dust as a compost and the dust as an energy source, and then are in the green and red, so the dust as an energy source is red. And then the perlite wall, so there's the blue and the yellow. So the yellow, or both of them are actually, there's such a difference in them because it's based on allocation. So mass allocation, when you actually mine perlite, it can go to 3 different industries: construction, horticulture, and industrial purposes. So in the yellow sense, it's actually the closest market to the end use, which in this case is Vancouver. So that the allocation is based on the production of perlite, construction grade perlite in an Oregon plant. And since they're in proximity to the largest horticulture region in the world, their main industry is horticulture. So only about 5% of their perlite actually goes to construction. Which means that you have to mine more originally to actually get it to the amount that you needed. So with the perlite in the blue, this is actually based on USGS market studies. So in that study, it said that 54% of all the perlite in the US is destined for construction. So that would be why there's like a large change there and throughout the whole process. And if you look at the whole thing, you can see that the hemp block wall has a lower footprint in all the categories except for global warming and ozone depletion. So you might think, well, that's weird that global warming is higher within those regions since it is a natural product. So if you look more closely at the actual impact of the block wall, you'll see that the hemp block wall is in red and transportation is in like the dark blue, so this. So you can see that transportation actually accounts for a lot of